This mini lecture, we're going to start looking at assembly language. Typical assembly language statement has 4 parts. And on the left, we have a label. Like, for example, this dark green here is an example. Start is the label. This is the operation, move.w, that says, in this case, it means move a word. And these are the operands. So it's moving this word. This number sign means immediate. That means take the number 0280 and put it in SP, which is the stack pointer. The semicolon out here indicates a comment, and everything after it is just a comment. So often they put a colon on the end of the labels, and they're in the far left in column 1. The operand is, our operation is one of the assembly language instructions, and this whole thing is going to be translated into machine code by the assembler. And the operands are the data needed for the operation. Sometimes they're not required. Comment follows the semicolon. So here's an actual example. This is a piece of software assembly program to blink the LED in one of the MSP 430 varieties. So we start here at the reset. This is the label where you're actually going to start executing your program. You need this .word reset down here, and the .end tells the assembler this is the end of the program. So you need to, down here you put in where you want to start, and the first instruction it will do is right there at reset. So this is stuff in the yellow box here is the program, the execution code here, and it all should be put after the .text directive. These little things right here in the second column with a dot in front of them are known as assembler directives. .equ, basically it sets the label delay equal to 0. So delay is now a variable you could use. It has a number 0 in it. And .bss, that also makes a variable. And it's set here as well. And so basically, if we look at this program here, it moves this number into the stack pointer. Then it moves the watchdog stuff here into the watchdog control register to stop the watchdog timer, because otherwise it will time out and stop our program when we don't want it to. And then this BIS is a bit set. .b means it's operating on 1 byte, and it's putting a 1 in the address P1dir, which is the output for port 1, pin 1, port 1. It's setting port 1, pin 1 equal to an output. This is port 1, pin 0, I guess you'd say. It's the first pin. Then you have your main loop here. It does XOR B, so it's checking to see is it a 1 here. And it's basically going to XOR 1 with this P out. So first of all, it's gonna change every time we go through this loop. So, and then this moves delay, which is 0, into a count register. This subtracts 1 from the count register, so this will go through 255 counts until, just keep going here, and finally this jump not 0 here, or it goes through, it just keeps counting. Finally it counts down and finishes up the 256. It hits this jump to main loop, jumps back up here, and it changes the light to the LED P1 out, either on or off. So that's kind of how this works. This top stuff up, like I said up here, that was where you put your variables up there. So that's kind of the basic introduction to how the MSP 430 assembly language looks a little bit. Now we want to look at some of the instructions for the MSP 430. So there are actually 27 instructions, which is very nice and not like 200 or something. And there are 3 instruction formats. There's double operand, single operand, and jumps. So jumps are categorized differently than the ones that need operands. So single and double operand instructions process words or bytes. You notice the last thing there was a dot W, where are we seeing? Right, maybe up, yeah, right here, move.w, that means it's going to a word. So let's go back here. And if it said .b, then it's operating on a byte. The default is word, so if you don't put .w, it just assumes a word. MSP 430 has an orthogonal instruction set, meaning that every instruction is usable with every addressing mode throughout the entire memory map. So you'll understand what the addressing modes are in a little bit. It includes a high register count, no paging, stack processing, memory-to-memory operations, and constant generator. So R0 is the program counter, and basically it points in memory to the next instruction that's going to be executed, and each instruction is 16 bits. That's really 2 memory locations, starting at an even number. And then what happens is when that instruction is starting to execute, it takes the number out of the memory and puts it into a register called the instruction register, and that's what we're going to do. That's the machine code for the instruction register. So then the first 4 bits are put into a 4 to 16 decoder, and depending on what the number in those 4 bits are, it will execute one of these 16 options. And this time we got 0100, so it's going to execute this option right here, which if you look at 0100, it's a move. So we're going to move something. Whoops. And over here, if you look up on the right-hand side here, we're gonna, this instruction really says move R5 to R4. And if you look at the 4 bits, that's the move instructions, then this is a 5. Then there were 4 bits that we don't care about, but here is 4. So we're moving R5 to R4. And so it takes 1 cycle to fetch the instruction. And so let's look at the instruction formats. There's more than just the one we looked at right there. Remember, these 4 bits right here were all 0 in the case where we were looking at that move from register 5 to 4. So the first 4 bits, the highest 4 bits, are the opcode. You looked at that already. Then they have the next 4 bits are the source registers. The next bit is the AD. This is the address destination bit. And then the next bit, 6, is either whether this is a bit or a word operation. And the next 2 bits are the address source. The source address is memory mode. In other words, what kind of, how are we going to get it from memory? There's several different ways of addressing modes, and this is the addressing mode for the source. And then we have the destination register on the end. Format 2, these are for instructions with 1 operand. It has actually 9 bits for the opcode. Then we're down to the whether it's a byte or a word. And then we have, since this is only 1 operand, it has the source operand addressing mode. And then the register right here. the one operand register. It might be source or data, whatever you're doing with one operand. Then format 3 are jump instructions. So there are actually 6 bits of opcode for the jump instruction, and then we have 10-bit of PC offset. So you can jump for as far as 10 bits will give you, from the present program counter. Now that's not the full. You can't jump the whole 64,000, registers or memory locations in the memory map. You can only go 10 bits worth. So that would be like 2 to the 10th is the furthest you could go away, or actually 2 to the 10th minus 1. Whoops. So let's look at format 1, the double operand, and see what instructions use this and what those instructions do. So we have add. Basically it adds the source, whatever's in the source register, plus the destination, whatever's in the source, plus the destination, and it puts that in the destination. And then we have add with carry, and it basically does the same, except it adds the carry on as well. Then we have de-add with carry, and this does a decimal add and carry to the destination. There's a thing called binary coded decimal, which is a way of using 16-bit numbers, but only we're just going to use them to represent only base 10 numbers. So that's what this decimal business is all about. Then we have sub, which is subtract. So this is does the source, and it subtracts the source from the destination and puts that in the destination. And then you have subtract with carry, and it subtracts the source and not carry from the destination. And then we have some logical. Those are all arithmetic operations. We have some logical things. These are bitwise operations. We've got AND, which ANDs the source with the destination, bit by bit. BIC, which is bit clear, and it clears bits in the destination. The bits that are cleared are the ones that are set in the source. And BIS, BIS, is bit set, so whatever bits are set in the source gets set in the destination. And then we have BIT, which actually tests, a bit in the source, the bits in the source with the bits in the destination. And then XOR, or actually this tests the bits in the destination, the source bits, the ones that are specified in the source. So XORs bit by bit between source and destination, puts it in destination. Then we have data instructions. Compare is basically to compare source and destination. It does a subtraction. Is there any difference? And move source to destination. So those are format 1 double operand instructions. Now let's look at format 2 single operand instructions. So there's some logical and register control instructions to begin with. RRA, which is roll register right, and that basically moves the bits to the right. So the most significant bit goes into, it just goes to the right most significant bit minus 1, and the least significant bit goes into the carry. And then there's roll right with carry, and that rolls the carry in as well. The RRA does an arithmetic roll, which doesn't do that. Then there's swap bytes, which swaps the byte order in the destination. It's a word, remember, so it It switches them from little endian to big endian, kind of idea. And then there's sign extend, so you can take a destination and turn it into a 16-bit number. And then there's push, which takes whatever's on the stack pointer and moves everything up one and puts a new number on the stack. We'll talk about that a bit later. It's a little bit more complicated. And then there's some program control instructions. Call is like it's like go execute this subroutine. And RETI means return from interrupt. So those are the single operand instructions. Then we've got format 3, which are jump instructions. So jump instructions, have a longer opcode right here and condition, and then over here there's 10 bits of where you're going. Jump instructions are used to direct the program flow. You want to go from here to another one. You can make spaghetti programming very nicely with assembly language. The condition on which a jump occurs depends on the condition field, consisting of 3 bits. And those are the Z, C, and N bits. So there's jump not 0, jump not equal, and jump 0 or jump equal, and jump no carry or jump LO. These are all the same. Jump not carry and jump LO are the same. Jump carrier or jump if the carry is set high. Jump negative, jump greater than, jump lower of less than, and then jump, just unconditional jump. So here's a quiz for you. You can see what you can do on this quiz.